discuss our next topic of differentiation. It is geometrical rule of differentiation. How differentiation, that means derivative, can also be expressed in a two-dimensional graph. So it is a two-dimensional graph having the axis, y-axis and x-axis. Then it has 2 points, P and Q. So P, the coordinates of P is x1, y1, and coordinates of point Q is x1 plus delta x, then y1 plus delta y. So this is a curve. This is a curve, and in this curve it has 2 different points, P and Q. So it is a line which is tangent at point P. So the coordinates are the OX1 and when x1 will change by delta x, this is the point where coordinates are x1 plus delta x. Okay. So difference is delta x. Then for y, it is that means at point Q, when y will change. So it is corresponding to this y1, but when y will change, it is delta y, only this part, small part, delta y. And total is y1 plus delta y. So coordinates of Q is x1 plus delta x, then y1 plus delta y. Now, what is the difference quotient? Difference quotient. So fx1 plus delta x minus fx1 by x1 plus delta x minus x1. So this is equal to y1 plus delta y minus y1, then x1 plus delta x minus x1. So this is equal to delta y by delta x. So this is the ratio of changes along the curve. Now while this is equal to y1 plus delta y, because y is the function of x. So for fx, we can write y. So when we will remove these brackets, then fx1 plus f delta x, okay, then fx1. So for this, we can, for fx1, we can write y1 from this relationship, because y is the function of x. Say y is an independent, dependent variable, and x is the independent variable. So y is equal to fx. For fx1 we can write y1, and f delta x we can write delta y, like this. So this is equal to, because after simplification, minus y1 plus y1 cancel, ultimately delta y. Say plus x1 minus x1 cancel, ultimately it is delta x. So delta y by, ultimately it is delta y by delta x. Now it will approach a limit which is called derivative of the function y is equal to fx at point P. So when q will approach, towards P, when q approaches towards P, is same as delta x tends to 0. So when q will approach P, this distance is a delta x, and change in x, this will reduce and reduce and reduce. Ultimately, change in x will be almost 0. So when q approaches P, it is same as delta approaches 0. Now, derivative is limit delta x tends to 0. So when delta x will be very, very small, almost 0, then this is fx1 plus delta x minus fx1 by x1 plus delta x minus x1. So this is equal to limit delta x tends to 0. We can write delta y by delta x from this relationship. And this is called the derivative. So when limit delta y by delta x and q approaches P, so this is equal to delta y by delta x, and this is equal to dy by dx. Generally, when we put limit, we express delta y by delta x as dy by dx. So in every book you will find that it is expressed as, derivative is expressed as dy by dx, not delta y by delta x. Because without limit, delta y by delta x, meaning is that what is the change in y due to unit change in x. But in case of derivative, what is the change in y due to very, very small change in x. That means when x is almost 0, tends to 0, what is the change? And this change is called derivative. Okay. So, and this dy by dx in books, in different books you find, whether in mathematics or even in economics. So it is the tangent. So at point P, the curve is tangent. This curve is tangent at point P. So at point P, it is called dy by dx. Then what is the rate of change? Rate of change of y due to very, very, very small change in x. So this is also called tangent of the point at point P. Then delta y by delta x is equal to is tan theta. We know in trigonometry, if you remember, the tan theta is sin theta by cos theta. So if this is the angle theta, delta y, that is the perpendicular, and delta x, that is the base. So perpendicular by base is the tangent of the angle theta. So this is called the slope. This ratio is called the slope of the curve at point P. And when we take a limit of this, then delta y by delta x is equal to tangent of the angle alpha. Now slope of the curve y is equal to fx, that means of this curve at point P is delta y by delta x. So it is the cosine. Delta y by delta x is a cosine, and delta y by dy by dx is a limit, and it shows the rate of change of y at a small change of x. So when we express derivative, we generally do not express as delta y by delta x, but we express as dy by dx. So it is a limit which shows the rate of change of y at small change of x. Okay. Now, in some books, we find that this is expressed, dy by dx is expressed as f prime x. That means it's the first derivative with respect to x. Now, when it is the second derivative, d square y by dx square, d square y by dx square is f prime prime x. That means it is the second derivative of the first derivative. It is the derivative of the first derivative. It is derivative of the function. Okay? In production economics, as I said earlier also, that the first derivative shows the marginal product. First derivative, marginal product. And second derivative, that means derivative of the marginal product, shows the rate of change of marginal product. We can find out whether the marginal product is increasing or it is decreasing, again increasing. It will depend upon the type of the function, the form of the function, whether it is a straight line or it is a parabola. So it will depend. Now, a differentiable function has derivative. When you say a function is differentiable, that means the function has derivative. If it has no derivative, we can't say that the function is differentiable. So with this, we conclude the geometrical rule of differentiation. One can go to my PDF and they can download, and this is in short. Thank you very much, and go on watching and share. Thank you.